heat exchangers, it turns out that if you go to a big power plant or a big refinery, there are several cases where you want a lot of heat. In the boiler for a power plant, that's where you want a lot of heat. In the distillation tower, when you're at a refinery, that's where you actively want heat. There's other situations where you don't want heat and you need to remove heat. And so a lube oil system would be a standard example there. The turbo machinery, they use sleeve bearings, the lube oil gets really hot, you need to cool that off. And so there's this device called a heat exchanger, aptly named, and its sole mission in life is to get heat from the hot stuff and transfer it to a cooler medium, and you'll find them all over any industrial plant. And the reason I bring them up is, as much as I love the big six predictive technologies, they really don't have much to say about heat exchangers, even though a heat exchanger is a completely ubiquitous item that you'll find at any of these power plants, and it's a really high maintenance item. So I'm excited. This is just top of mind. So now that you've integrated with ignition, what you can do is heat exchangers are just fluids flowing through pipes. And so you've got pressures and temperatures and flows of a hot fluid and of a cold fluid. Vibration, as much as I love it, can't tell you anything about the failure modes, but say that it's a tube and shell heat exchanger. If you get a lot of gunk on the tube sheet, that'll prevent flow. You can monitor that inside of ignition. If you have a failure mode like biofouling, incidentally, biofouling is a very common problem. It simply means that you get literally biological organisms growing on the surface of the inside of the tube, and that prevents heat transfer. So that's another very standard failure mode that we got to take maintenance action on, as we would record inside of Maintain X. But you won't see that in vibration or in thermography. It's buried inside of the machine, but you will see it if you're tracking the temperature difference or the efficiency overall of the heat exchange. And so now, with what you've done for rotating machinery, you can go to a condition monitoring platform and get those failures. Vibration does a great job there. With non-rotating machinery, stationary equipment like heat exchangers, you can monitor that and have alarms set on that inside of ignition. And now both of those integrate to Maintain X, which is the place where you would execute the frontline work. It's the most common request that I get generically, like how do we bring together plant historian / SCADA data with the predictive data, and guess what? We now have all three mixed together. Condition monitoring, SCADA data and ignition, and you guys. And suffice it to say, I'm pretty psyched about this.